So in this problem, we're given a situation at an amusement park ride. So first, it tells us that we have 700 people in a line, and the people getting on the ride from the line is 800 people per hour. And this graph right here gives us the number of people entering the line at any given time. So the first problem, we have to find out how many people arrive at the ride, so basically enter the line between time 0 and time 3. So basically what we have to do, the number of people equals the area under the curve from T0 to T3. So basically this area. So since we don't have a function for R of t, we have to actually find the actual area. So what I did first is I split this figure into two trapezoids right here, and I found the area of trapezoid 1 and trapezoid 2. So for trapezoid 1, you have to find the area. So it's 2 times 1,000 plus 1,200 all over 2. So the 2's cancel out, and basically you get 2,200. And the next part, for trapezoid 2, you do 1 times 1,200, which is one of the heights, plus 800, which is the other height, over 2, and that, after the math, gets you 1,000. So you do 2,200 plus 1,000, which gets you 3,200, which is our final answer. Alright, for B, we have to find out if the number of people in the line is increasing from T2 to T3. So we know that the line is increasing because here's the reason. The line is losing people because the people are going into the line at 800 per hour. 2. The line is gaining people from 1,000, from 2 to 3. The line is gaining people at 2 at 1,200, and at 3, 800. All those numbers are above. From 2 to 3, those numbers are greater than 800 people. So the line is gaining people at a rate above 800, gaining above 800. So since it's gaining above 800 people per hour from 2 to 3, the line is increasing because there's more people coming into the line. So now for C, we have to find out when the line is the longest, at what time T is the line the longest, and how many people are in the line at that time. So for here, we know that the rate of entrance of the line is 800 people per hour. So if the line is losing people at 800 people per hour, so the line would be longest. So the line would be the longest from the time where R of t is R of t is greater than 800, and all the times at which that is true. So this is true from 0 to 3. So from 0 to 3, where R of t is over 800, the line would be the longest, because from 0 to 3, the line is gaining people at a rate above 800, which means the line is gaining more people than it's losing. So, if it's gaining more people than it's losing, the line is getting longer. So from 0 to 3, it's always above 800, and the line is getting longer. That means at t equals 3, when it finally starts to go under 800, because t at 3 equals 800, the line would be the longest. So at t at 3, the line is the longest. Now the second part is how many people are in the line from 0 to 3. So we know that there's 3,200 people gaining in the line from 0 to 3, since we find that out in part A. Now we have to add that to 800t. This is because we know the line is losing people. Actually subtract 800t, because it's losing people at a rate of 800t. So the t we find out would equal 3, so it would be 3,200 minus 800 times 3, which equals 3,200 minus 2,400, which equals 800. And that's our answer for C. Now for D, it's asking us to find an integral expression, or make an integral expression that gives us when the earliest time in which there is no longer a line for the ride. So in the problem, we find out that there's 700 people initially in the line, and the rate of entrance to the ride is 800t. So we do the initial, which is 700, plus the rate of entrance into the line, which is R(S), which is R of t, minus the rate of entrance to the ride, which is 800 at any given t. So, and we set that whole thing to 0 because we want to find it when there's no longer a line. So in this one, to actually find the time, we have to solve for t. And basically, that's it. Thank you.